Welcome to the Crazy Hat Chemist. So the last video in this series here of solubility. Bam! Solubility example number 11. So complex ions. Remember the solubility of complex ions in the acid-base unit? Here's another one. Calculate the solubility of silver chloride in a 0.75 molar ammonia solution. The solubility product constant for silver chloride is 1.6 times 10 to the negative 10. The constant for the formation of silver ammonium complex ion is 1.5 times 10 to the 7. Okay, so I want you to realize something here, that the solubility product constant for silver chloride, of course, is times 10 to the negative 10, is a reactant favored reaction, right? That's what that number tells you. Also, for the formation of the complex ion, that is times 10 to the 7. That is a product favored reaction. We're going to be combining these together here. Okay, so I got a silver chloride, that's an insoluble precipitate, dissociates to a very slight extent to silver ion and chloride ion. 1-to-1 mole ratios for everything. Again, those equilibrium arrows lie far to the left. There come times 10 to the negative 10 as the KSP value indicates. The KSP here is the silver ion times the chloride ion is equal to 1.6 times 10 to the negative 10. Okay, then here is silver ion plus 2 ammonia produces silver ammonium complex ion. Notice that this equilibrium arrow lies to the right. So this is the K of formation. So the K of formation is like any K, that's products over reactants with the stoichiometric coefficients as exponents. This one is 1.5 times 10 to the 7. Okay, again, this is a product-favored reaction, therefore those arrows have been changed. Okay, there are no solids or liquids in that one, so that's why everything is incorporated into that, because it's all aqueous. Okay, what we're going to do is we're going to sum up these two reactions here. There's only one thing that cancels out, everything drops down. And the only thing that cancels out is the silver ions. They cancel out. There's one on the reactant side, one on the product side, those cancel out. You get silver chloride as a solid plus 2 ammonia gives you silver ammonium complex ion and a chloride ion. Notice that equilibrium arrow is lying to the left, as I'm going to show mathematically in just a second here. So the K net here, if you remember back to the equilibrium unit, when you add up equations, you multiply the K values. So I'm going to take the KSP times the K of formation. I'm going to multiply those two values, which I've plugged in right here at 1.6 times 10 to the negative 10, times 1.5 times 10 to the 7. The product of those two is going to be the K net of this equation, which is right here at 2.4 times 10 to the negative 3. Okay, and then we have this K net equation. Products over reactants, stoichiometric coefficients as exponents, but what's not included? Solids. That's why the HECl solid, that is the insoluble precipitate, is not included. Okay? I want you to notice one thing about this here before I continue on and do this ice table here that I just put up there. And that is, I want you to notice that this reaction here, the sum of these two reactions has made a more product-favored reaction than just having the silver chloride, as being a very reactant-favored reaction, combining it with a product-favored reaction. This means that you're going to take some of the silver chloride and now it's going to be pulled out, the silver chloride solid is going to be pulled out of its precipitate and go into solution with the formation of the silver complex ion. So it's shifting the reaction to the right. Even though it is still reactant favored, it is shifting it to the right. So let's come up with these values here in our ice table. Remember, solids are not included for anything. The initial here for the ammonia is in right here. Okay, and that was given at 0.75 molar. Okay, so I'm going to plug that value in there. Okay, and zeros for both of my products, just like any equilibrium reaction, right? Okay, all right. So now we're going to come up with the values at the change. And you notice that there's that 2 coefficient in front of the ammonia, so I need to account for that. Also, it's on the reactant side, so I need to account for that, and that's why it's a minus 2x. It's a minus because it's on the reactant side. It's a 2 because of the 2 stoichiometric coefficient. Now I'm going to get my products. That's going to be a plus 1x because it's a stoichiometric coefficient of a 1 and a plus 1x here. I'm going to sum up these two values here, that is the initial and the change columns. I'm going to get my equilibrium here at 0.75 minus 2x. I got an x and an x. I'm going to plug all this information into my k-net equation, which is right down there at the bottom. I solve for my k-net value, and that is 2.4 times 10 to the negative 3. That's going to go right there. I have my value for my complex ion, that is the silver ammonium complex ion, and that's X. I also have my chloride ion, and that's going to be X as well. Okay, and I also have my ammonia, and that is going to be 0.75 minus 2X. I'm going to plug all this in. Don't forget about that coefficient on the ammonia as an exponent there in the k-net equation. So let's plug all this information in here. So this is what I get. I get 2.4 times 10 negative 3 is equal to x times x, that's x squared, in the numerator. In the denominator, I have 0.75 minus 2x quantity squared. Okay, I'm going to take this to the next slide because I'm running out of space. I'm going to still solve for x here in just a second here. All right, same thing that I had before on the previous slide. We're going to take the square root of both sides. Okay. So I'm going to take the square root of the left-hand side, square root of the right-hand side. That's what I've got right there. All we're doing here is solving for x. Okay, taking the square root, I got 4.9 times 10 to the negative 2 on the left. On the right, I got x in the numerator and 0.75 minus 2x in the denominator. You're going to cross multiply here. You're going to solve for x. So you're going to get 4.9 times 10 to the negative 2 times the quantity 0.75 minus 2x is equal to x. I'm going to distribute that 4.9 times 10 to the negative 2 over both the terms inside the parentheses. Okay, that's what I've got right there. I'm going to combine my x terms and my non-x terms, put my x terms on one side, my non-x terms on the other side. That's what I've got here. And now I'm going to divide by my coefficient in front of the x. I got 3.3 times 10 to the negative 2. That means 3.3 times 10 to the negative 2 molar. That's the concentration. What is that? So 3.3 times 10 to the negative 2 moles of silver chloride dissolves in 1 liter of a 0.75 molar ammonia solution. That is the answer to that problem. That is a super cool problem. That includes so many different things here on this problem, just like on the previous problem. We got a complex ion on this, and we got that precipitation thing. Okay, so I am the Crazy Hat Chemist, and I got a great hat here. Whoa, yeah, look at that. And don't forget about, you can always get a t-shirt and a sticker. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I'm going to see you next time for a whole entire another unit. Until then, have fun with the chemistry problems, and remember, okay, chemists have the solutions to all your problems. Bye for now.